Welcome back, everybody. This video is going to have applications of quadratics and different methods to solve. So this first one, we have the height of a triangle 6 meters more than its base. The area of the triangle is 56 square meters. What's the length of the base? We're going to start out with the area of a triangle formula. We have A equals 1/2 BH, 1/2 base times height. That's the area of a triangle. So they tell us the area, which is 56. B for base, and they don't tell us the height, but the height is 6 more than the base, so B plus 6. And notice how everything matches up here. Here's the area with 1/2, B for base, and here's this formula for height, given that first sentence up here. First thing we're going to do is multiply both sides by 2. That'll get rid of the 1/2. 2 times 56 is 112. And then we're also going to distribute the b to get b squared plus 6b. Next up, we want to get everything to one side, put the quadratic in standard form, so to speak. So we'll have 0 equals b squared plus 6b minus 112. Since we're running out of room, we'll continue our work over here. Now, this does factor, so we'll set up the factoring with b and b. And we ask ourselves, what factors of a negative 112 add up to 6? Turns out 14, positive 14, and a negative 8. Negative 8 times 14, negative 112. Positive 14 plus negative 8 is the positive 6 we see here. So then we're solving these two equations. B plus 14 equals 0. B minus 8 equals 0. We get one answer of b equals negative 14. We get another answer, b equals 8. The negative 14 does not make sense because we can't have a negative measurement, but b equals 8 does. The base of the triangle is 8 meters. Next question here. Ashley has a rectangular garden that measures 9 by 13. She wants to increase the area to 192 square meters by increasing the width and length by the same amount. What will the length of the new garden be? Well, here's the original. 9 by 13, here's 13. And if we take 9 times 13, we get 117. But what she wants to do is make a larger garden. And then it will be about like this. And notice that the amount, we're going to increase the width and the length by the same amount. And the new area will be 192. So to set this up, we know area of a rectangle is length times width. Our new rectangle is going to be 192 square meters. Instead of 13 and 9, we have to add to that x. X plus 9, x plus 13. Alright, what we'll do is FOIL out the right side of the equation. We'll do x times x to get x squared, 9x, 13x, and 117. We will do a couple steps in one here just to save time. We're going to take away that 192 from both sides. We're also going to add together the 9x and the 13x to make 22x. So we have x squared plus 22x. And then 117 minus 192 is a negative 75. Turns out this does factor. Factors of negative 75 that add up to 22, that would be a positive 25 and a minus 3. Now we can set each of these equal to 0. We get x equals negative 25 here, x equals 3 here. The negative 25 doesn't make sense, the 3 does, but we're not quite done. They want to know what's the longer dimension. We're going to add 3 right up here to the x plus 3, because remember that's the longer dimension. And 13 and 3 obviously make 16. So the new garden is going to be 16. If they asked for the shorter side, 9 plus 3 would have been 12. All right, another one. Here we have two circles. And the radius of the outer circle is 2x. The radius of the inside circle is 6 meters. The area of the shaded region is 160 pi centimeters. What is the value of x? Okay. Well, we all know the area of a circle, pi r squared. To get this shaded region that they're talking about, it's going to take the big circle minus the smaller circle. The shaded region, they say, is 160 pi square centimeters. Big circle, pi times its radius squared. Smaller circle, pi times its radius squared. The big circle has a radius of an expression, 2x, which is a little strange. The smaller circle, radius of 6. All right, so as you can see, the only variable we have here is x. And notice what we can do. Each term has a pi. We can actually divide everything by pi, and that follows the rules of equations. What you do to one side, do to the other. And here's what we have. 160 equals 4x squared. That's what we get when we take 2x squared times itself, minus 36. We're going to solve this like a normal equation. We're going to add 36 to both sides. We get 196 equals 4x squared. We're going to divide everything by 4. 196 divided by 4 gives us 49. And then we take the square root of both sides. Now keep in mind, we do get two answers, plus minus 7, but the only one that makes sense is positive 7. If we had negative 7, it would be a negative radius, which doesn't make sense. X equals 7. All right. Ted throws an object straight up in the air with an initial velocity of 54 feet per second from a platform that is 40 feet above the ground. He uses this formula. H of t is negative 16 t squared v sub 0 t plus h sub 0. V sub 0 is the initial velocity. H sub 0 is the initial height. How long will it take to hit the ground? All right, well, let's make this equation based on what we know. H of t equals negative 16 t squared plus v sub 0 t, the initial velocity 54. I'm putting that in for the v sub 0. The initial height is 40. All right, and to hit the ground, we're setting it equal to 0. So we're solving this quadratic equation, setting it equal to 0, because the h of t, that's the height, we wanted to know when it hits the ground. Unfortunately, this doesn't factor. We can solve it using our friend, the quadratic formula. Negative b, the b number. Now, just so you know, our a number here, here's our b number, 54, c number, 40, a is negative 16. Negative b plus or minus 54 squared, b squared, minus 4 times a times c. The a is the negative 16, c is positive 40. Underneath here we have 2 times a, which is 2 times negative 16. All right, we're going to go about simplifying all of this. Negative 54 plus or minus square root 54 squared is 2,916. Negative 4 times negative 16 times 40 is a positive 2,560. 2 times negative 16, the denominator is negative 32. Let's simplify some more. Negative 54 plus or minus square root of 5,476. All that's divided by negative 32. Turns out 5,476 is a perfect square. We'll continue our work up here. The time when it hits the ground, negative 54 plus or minus square root of 5,476 is 74. All that's over negative 32. All right, we're going to get, if I do negative 54 plus 74, that gives me 20 over negative 32. And that decimal comes out to negative 0.625. And that doesn't make sense because you can't have negative time. However, negative 54 minus 74 is negative 128 over negative 32. That divides evenly to positive 4. and that is the time it takes to hit the ground, 4 seconds. Keep in mind, another way to do this, graph this equation on Desmos, look for the x-intercepts, and that tells you that those two x-intercepts should be at these two numbers right here, negative 0.625 and positive 4. Last one, this is kind of a different one. Tim wrote an equation, x squared plus 5x plus 126 equals x squared plus 17x plus 66, to show that the area of a changed rectangle is 126 meters greater than the area of the original rectangle. How did the rectangle change? All right, well, here's kind of a visual of what happened. Here's the original rectangle. And apparently, Tim, the original, if we add 126 square meters, that's going to equal the new rectangle. It's a little bit bigger. Alright, so this is the new one. And this was the old one. Now the old one, apparently, according to the equation, can be represented by this expression, x squared plus 5x. We still have the 126, not really doing anything mathematically, just hanging around. The new rectangle can be represented by x squared plus 17x plus 66. Sorry, a little bit sloppy there. Let's try to factor everything and see if that helps us out here, makes sense of this. If I factor out an x from the first term, the first rectangle, I'm left with x plus 5, and that can represent each side of the rectangle. Here's the width and here's the length, x plus 5. The other side can factor. Factors of 66 that add up to 17. I think 11 and 6 do the trick. So 11, 6, and those can represent the width and length of the new rectangle. There we go. Now the question is, how did the rectangle change? Well, look at the relationships. This width to this width. We go x to x plus 6. Look at this length to this length, x plus 5 to x plus 11. Looks like we're adding 6 to each side. It's not really anything to solve for here, but we're just matching up the corresponding sides here, and they go up by 6 each time. Alright, so there's 5 different problems, different ways to solve applications of quadratics. Hopefully this video helped. Thank you very much for watching.